Hey guys, let's check it out. This is the trapezoidal rule. And we've got a question from our textbook. We have this is actually the online version of one of our books, and it's the green book if you want to know more about it. Trapezoidal rule is written. Let's see, where do we find it? We can reference this from text. It's h over 2 or delta x representing our h. And let's see here. So think about the area formula for a trapezoid. The area formula for a trapezoid is h over 2 times base 1 plus base 2. That's right, h over 2 times base 1 plus base 2 area of a trapezoid. We're going to use that same area of a trapezoid structure when we design the trapezoid rule for finding the approximate area under the curve. So base 1, well, h in this case, if you think about the sideways picture of the graph, let me try to, quick sketch some sort of a curve here, and then we drop in some vertical lines. These vertical lines are function outputs. We are connecting each of the endpoints in some sort of trapezoidal, right trapezoidal, if you'll allow it, shape. And so moving all the way around, we have a delta x along the edge. The delta x is actually the height, right? If you take the paper and let's see here. So we've got, our base 1, base 2. We would say like vertical would mean, height, but you got to look at this a little bit sideways. Each of these lines that are vertical are actually base edges for our function. We know the length of each of them because of the function's evaluation. So going from x sub 0 to x sub 1, x sub 2, x sub 3, x sub 4, x sub 5, we are able to compare, their respective y values because of their heights, right? Like y sub 0 and y sub 1, y sub 2, etc. They're totally dependent on what our x numbers are. So like x sub 0 goes to y sub 0. Those indices are the same indices for the y coordinates as well. But that line, that y0 line, is actually a base, right? Turning this thing sideways, that is base 1 of our area formula. So y sub 0 plus y sub 1 over 2 is our interval, plus y sub 1. Well, that's our height, right? Our height of space 1. Each of these are delta x in height. So when we talk about adding up trapezoids, we're not going to worry about writing down delta x every single time. It's just going to be factored in. But we do have our base 1 plus base 2 amounts. y1, well, let me write it this way. y2 plus y1. I think I'm going to switch that around here. I'm going to put y1 kind of next to the other time that I mentioned y1. So y1 plus y2 over 2 plus continuing the trapezoid, maybe view it sideways, that the third subinterval has a base 1, base 2 edge of y2 plus y3 over 2, and last of all, y3 plus y4 over 2. Okay, so that is our trapezoidal area. Let's get some extra paper out here. So that extra paper allows us then to do one more y4 plus y5. Y2, let's see, y1, y2, y3, y4, they're all mentioned twice. There's the fourth subinterval and the fifth subinterval. So because they're all mentioned twice, one thing that we notice is we can combine. We can go ahead and, I think I put the over 2 in the wrong spot. I wanted to show that the over, well, wait a minute. They're all divided by 2. So h is delta x, the sideways view of the heights. The divide by 2 is actually, since they're all divided by 2, let's actually like make the divide by 2 happen that way. So there's not divided by 2 inside the parentheses. It's all related to the outside of the parentheses, cross those 2's away because we factored them out. So now if I rewrite a little, clean up the uncleanliness, we have delta x over 2 multiplied by y sub 0 plus 2 y sub 1s plus 2 y sub 2s plus 2 y sub 3s plus 2 y sub 4s plus 1. There's only that 1 on the end, y sub 5. Well, there you have it. There's our trapezoidal rule in action for a random function where you see that, the bases on the inside, right? The bases that are between subintervals. They're shared by the top and bottom subinterval, the intervals that are left and right of those values, so we need 2 of them. All right, 1 to 2, 2 to 3, 3 to 4, etc. But the only ones that are singleton are the y sub 0 and the y sub 5, because they don't share any other edge with another shape. They're not used more than one time, so they should only show up one time. Now we have these values of information from this problem. It's a little bit too big there, so resize. But we do know that n equals 6, so to go from 1 to 13 with 6 subdivisions, let's just check. Let's see here, 1, 3, 5, 7, yeah, 9, 11. So okay, that is moving up by 2s. And then the respective y values that go with them, right? So 11 is going to be used 1 time. Let's delta. So delta x equals 2. And then from there, we're going to build out the rest of the formula. So delta x, that'd be our height. Height equals 2. So the bases will be 11. Oh, this is sideways, right? We had to turn the shape of this function sideways to talk about bases, because it's not like the way we want to think about it. We don't want to think about it as the lines actually represent bases. You know, they're heights. Okay, so the bases are y sub 0, or 11, plus 2 times 9, plus 2 times 7, plus 2 times 9, plus 2 times 13, plus 2 times 14. What's left? 2. No, not a 2. Just 17. Only the ones on the edges are only mentioned one time, but the numbers on the inside between intervals, they're used in both intervals to generate the interval. So now we have 11 plus 2. I'm going to factor and group. So 2 times all of these. 2 times 9 plus 7 plus 9 plus 13 plus 14. Do I have to use calculator? Yeah, I guess so. Okay, 9 plus 7 plus 14. 9 plus 7 plus 14. That should be, what did I write? Why did I write that? 9 plus 7 plus 14, but 10 plus, okay, so 52. So in other words, 11 plus 2 times 52 plus 17, 28 plus 104, and that amounts to 132. 132. And plug that in, see if that works. We multiply by 2, right? We can't. We multiply by 2 because delta x equals 2, the trapezoidal rule, so it's delta x over 2 times all of our functions' heights as they're defined. So 2 over 2 times 132. 2's cancel. Yeah, that was actually the answer. 132 is what we'll type in here. And good job. Thanks for watching this video.